Hi, and welcome to another Hopper Getting Started video. I'm going to show you how to get Hopper up and running on a device from Adafruit that's very similar to the Raspberry Pi Pico. It's got the same processor in it as the Adafruit Feather RP2040. I'm going to show you how to get the development environment up and running on Windows so that you can develop in Hopper for this device. It should take about 5 minutes. It's similar to developing using other environments like the Arduino environment or the MicroPython environment. Hopper is a modern semicolon and curly brace language like C# or Java, and it has a built-in development environment and debugger. So let's get going. So I can tell you a bit more about this device. It has a reset button, which the Pi Pico does not, and it has a USB-C plug, which I far prefer. They're a bit more robust. They put the boot select button in a really convenient position because you can squeeze the board and hit the button at the same time with one hand. And it's got a LiPo battery connector as well as charge circuitry on board. It also has a NeoPixel LED, so blink can be a little more interesting. And that's what we'll demonstrate today. So let's see. In the description of the video, there's be a link to this page, and it will also be a link to the Hopper repo. So this is releases on the Hopper on the Hopper repo. If you go to any GitHub repo that does releases, you'll see it on the bottom right here. There'll be a thing that says releases. So you go to release, and we've got the latest ones here. Now we're going to download two files. We're going to download the Pico UF2 because this is a Pico compatible board like that. So we'll start downloading that. And we're going to download this zip file, which is the entire Hopper development environment here. Right. Now this zip file includes an executable. So I'm going to get a warning from the browser that it's got an executable in it, and it's not signed yet. It will eventually be, but it's not. So I'm going to just say download this suspicious file anyway. All right. So now I should have both of them. And I'm just going to drag the zip file onto my desktop. There we go. And I'm going to drag the UF2 file onto the desktop. There we go. Now, the way you flash one of these standard environments onto your device is you hold down the boot select button there with my right finger there, and then you plug in the serial port. And then it appears when the boot select button is held down, it appears on as a USB drive on your machine called RP2. And all you do to flash the device is you drag and drop that UF2 file into that folder. And just like that, you've now got the Hopper development environment on your device. So we can close that window. We're done with that. We can delete it. Now, this is the Hopper environment. It's all in one folder in a source tree. So we can drag that to the desktop. It's doing that. So it's unzipped to my desktop. So I can delete the zip file. And I don't need that. And if I open this in the bin folder, this executable here is the one that Windows was complaining about. So it's going to give me another warning when I try to run it, and I'm going to ignore that as well. So more info, run anyway. All right. So this is the Hopper console, the development environment. So let's switch to full screen on that. Similar to the DOS or Dire, the DOS console. And the entire environment is in here, the entire tool chain, compiler, optimizer, code generator, the debugger, the editor. So, and if I go to source samples, there's sample files. There's a folder called MCU for microcontroller sample files. And as I mentioned, we've got a RGB blink. So we're going to light up that NeoPixel as our demo. So I'm opening it in the editor. This editor is written in Hopper as well. You put in a define here for which device you want to use. If you don't have that there, and you build, okay, we also want to say, this is kind of important, generate iHex. It needs an iHex file to transfer. So you need to do this if you're developing for a microcontroller rather than just making Hopper applications to run on Windows. So we'll do that. And if I try and build right now, it's going to offer me save. So yes, I want to save and build. If I want to avoid that message, I can just say save on build over there. So those two options are pretty common. Now let's build again. In the bottom of the screen, we see an error message. If we to use MCU unit, define the target board at the start of your program. And if I double click on this, it'll show me where. So it's got a whole set of comments here about which board to define. So most likely we want this one, the most common board. Unless it's got Wi-Fi, then it gets a bit more complicated. Control backspace takes me back to here, and this is the define that I wanted. So now let's build again. We should get no error message. Yes, and all these options are on the menu. The shortcut keys I'm using, they're all on the menu described here. So now I'm going to press F5 to launch the debugger, or I can click on the menu and go there. There we go. So we've launched into the debugger. It's uploaded my Blink RGB to this device. It connects to the most recent serial port if you don't give it a default. There's also in the console a port command so that you can select the port you want, which is helpful if you've got more than one device on your machine. Okay, now if I F5, it should just load that up and start blinking, and there we go. So we have our blinkage. So that's all it takes to get up and running with the Hopper development environment on Windows. And unlike the Arduino environment, I can go Control C here and I'll stop in the debugger. Now I can single step through. So I can say, okay, make it blue now. Oh, show it, yes. And now make it black, 000, show it. That's all. Go around and make it red. There we go. So debugger, and I can step into these. A lot of Hopper is written in Hopper, so I just stepped right into that, and it's stepping through the Hopper library here. And if I switch out of that, go with the debugger has call stack over here. You can click on variables to see what they are. You can set breakpoints. So let's break after it turns blue, shall we? Put a breakpoint there in F5, and I'll have to switch back to the one of the video, and yes, it stopped on the blue. So now I can say, okay, move the breakpoints to here, so it should stop on the red if I press F5. There we go, it stopped on the red in the debugger. All right, thank you for watching. I look forward to feedback. If you get stuck in this process of getting up and running on Windows, and the same works for a Raspberry Pi Pico or Pico W, pretty much exactly the same steps. If you get stuck, please reach out to me. We've got a Discord server, and I'd like to make this process as smooth as possible just to get up and running. So if you run into any hurdles, let me know. And thank you for watching.